Good evening, all. Today we will learn about vertical geometry, that is profile, and also the superelevation. How to design the superelevation, that also we will learn today's class. Okay. Uh, I have taken the surface from the Geo Google Earth. I will show that what surface I took. Please mute. Okay. This surface I was took from the Google Earth. You can see.
Screen is not visible.
1 minute. Uh, is it visible right now?
Yes, sir.
Not yet.
Okay.
Yes,
Yes.
now it is visible.
You can see this is a Nagpur area from Goa. I choose one alignment nearest to the Nagpur area. You can see this is in the Varda district. I have chosen from this to this area like this. I downloaded the SRTM data. I will show that. You can see this is a SRTM data from Varda district. This much I have taken, right? You can see. I will zoom out 1 minute. What we taught yesterday, that same process I followed and downloaded the SRTM data in this. And I have created the surface known as existing surface. You can see here. And added the contours lines of SRTM. And I have generated the boundary and contour lines. You can see these are all the contour lines. And this is a greenery is a boundary of that surface. Okay. Then I marked the alignment. I will show 1 minute. I will add these all contour lines first of all. Okay. And in the surface, I will hide in the surface. That is only I will took we will took border only. Okay. All contour lines will be now gone. Right. For this also, I will add the feature attributes. Okay. Now you can see this is the Samruddhi Highway. You can see this is the topmost is the Samruddhi Highway. You can see this is Samruddhi Highway from Nagpur to Mumbai. The alignment will start from the Samruddhi Mahamarg in the Varda district and it will goes to the Goa, right? Same I selected that area and I have taken the alignment. What in last classes I said that like that I took the alignment and I've taken the curves also, right? Same I added all the curves along the alignment. You can see for seeing what the curve and radius would taken, please click on the alignment and the geometry editor. You can see it is last icon, alignment grid view, right? Click on that. You will get the all the uh, curves that are taken in this alignment. See, I will zoom out. You can see this much curves are added, right? You can see minimum radius it is four. You can see there are four curves, right? 700 radius, 1000 radius, 1000 radius, 800 radius. And the minimum spiral length, I added 130, 130, 80, 80, 80, 80 for all that, right? It is showing the yellow icon, that is a danger icon, right? Because of I have not set the alignment properties, that is design speed criteria. That's why it is showing danger icon, right? In the alignment property, after clicking alignment, go in the align property, then go to the design criteria at the last step. You can see I selected 100-meter speed, that I will took IRC standards, that is now it is a 6 lane. Apply, okay. Now you can see the alignment is done, right? Now afterwards we move to the plan and profile, right? We need a, now we generated plan, now we need a profile, right? For that we will go in the home tab. You can see there is a profile. Click drop down icon, create surface profile, right? Click on that. Now it is a center alignment is a NG center line. I have selected that. And we have existing surface, that is we already generated. Click on that and click on add icon. You can see here this add icon. Right now the existing surface added to the profile, right? Now then click draw in profile view, right? This pop-up window will open. In this you will select already NGCL already selected. Now profile view name, it is a parent alignment and profile view station. Now you can name it as design profile NG Nagpur Goa. And profile view style, already template is incorporated in this, that's why it is showing SADCPL PV style. Select that, then go to the next, click on the next. Now it is a around 0 to 51.408 meter road it is there. It is around a 51-kilometer road. As you can generate the profile for specified range also, or total alignment also. Now I select the total automatic, then next icon. Now you can see the first one is profile view height, right? In this you can see in the automatic there is a minimum 246 and the maximum is 346, right? You can keep at it is same as automatic, or also you can give some values nearest to that values. Now I will specify user specified in this. I will take 140 as a minimum value. You should give minimum value is less than the minimum value, right? Now it is for 246. I am giving 240 as a minimum value, and maximum it is 346. Now I will give 350, right? You need to give maximum above that value, right? Then next I will click on the next, click on the next also, then next, then create a profile view, right? Now I'll click any point above the profile. You can see now the profile view generated. I will off the geolocation. You can see this is a profile, right? You can see it is almost 51.409 kilometer, right? It is all profile. You can see, there is a, at the starting point there is a high elevation, and it is decreasing, it is through somewhat high elevation, then it will goes to the this value, right? You can see in the bottom there is a bands. These all values are known as bands in the civil 3D. Like you can see first one is a cut fill. Cut fill is the difference of the FRL and OGL. Now it is taking 0 0. Why, I will tell you that. Then after that there is a FRL of proposed road. That FRL of, we not yet generated the FRL. FRL we not yet started. That's why it is taking the ground level only, right? Then next it is the existing ground level at center, right? It is the existing ground level at that alignment location, right? At this alignment, what is existing elevation they showing in this, right? This is a existing graph only. This all greenery, it is a existing graph, right? Then next it is a chainage. Chainage is nothing but kilometer from starting to, it will go by increasing 20 meter at the interval. It will goes and end at the end chainage, that is 51409, right? Then next it is a vertical schematic. I will tell after adding the profile FRL line, and then the horizontal schematic. Horizontal schematic, it is known as a horizontal geometry, right? Horizontal geometry, what we done in the alignment, like, right? You, here we have curve, right? 9 kilometer. You can see in at the 9 kilometer chainage, it is right now flat line, right? You can see from here, horizontal schematic, it is a flat line, right? You can see it is a total flat line because there
Why
is a
it comes
no
flat
curve.
line?
What?
Why it shows flat line?
I'm telling that only. It is all flat line because there is a no curve at that chainage, right? The first curve is there at the 9 kilometer chainage, right? There is a total, it is a flat line. There is no curves, right? You can see at chainage 9 kilometer. You can see this is a curve, right? Here you can see the first one is transition length and curve radius, then the transition length in and out. This transition length is in transition and this is the out transition, and there is a radius of 700 meter curve is provided like this. And then afterwards it is also flat line. There is no curve, that's why it is showing flat line. Where there is curve, that time only it will show curves, right? You can see the first one curve, it is a upper one curve, right? You can see at the chainage 9, it is a curved around the above, right? Because the curve is on the right side. If it is curve is on the right side, then it will go in the upper direction. The next curve, you can see this curve is a left direction curve, right? So it is uh, showing below that. It is at chainage 1600. You can see it is below down, below the curve, like, right? Likewise, all curve will be there. Right now, we will draw the profile. That is the where the alignment type top of pavement is there. That known as FRL, finished road level. That we will draw right now. You can see in the profile, in the own tab only. In the profile, click drop down. In then next, you can see the profile creation tool. Click on that. You will ask to select the profile. Now I will select the profile. Then I will name it as a design profile, right? Then the profile style, I will select uh, that SSDCPL design profile, right? In the profile label style, I will select SSDCPL DPL labels. right? Same like that, we need to select design criteria for the vertical curves. What we done the for the horizontal curves, same we are doing for the vertical curves. In the design criteria, select use criteria based design. Click on that and select the IRC code. Now I select IRC code. Okay. Now I for vertical curves we will use IRC SP23. Click on that. Now all is okay. Now click OK. Right now the same bar will come after clicking the profile. In this also same notations are there. First one is curve and vertical tangents, all adding items are there in the first break line. You can add the vertical point of intersection, that is point of vertical intersection, PVI, right? We can delete that, and all seeing all the curve details, you can click on the profile grid view. Like that, there all the tabs are there. Now first we will go in the first tab, that is draw tangents. You can take draw tangents with the curves also, or draw tangent. We will generally take draw tangents only. After that we will add the curves, right? Now I will take the start point here, uh, right? I took start point. I will go right now it is around 740 meter. You can cut it. You can see I will cutting the this area. You can see first in the elitarian that cutting filling will be more likely in the direction of depth, right? Now I will select the, I will draw normally the profile.
How to decide cutting and filling?
It is generally we need to draw the by balancing the cutting and filling, we draw the alignment. There is no criteria based.
Okay.
Likewise, I am. It is a expressway. That's why I am not taking in the cutting section. Right? Expressway will be at the above the ground level. Expressway generally drawn above the ground level, around 5 to 6 meters above the ground level. Right? That's why I took all the profile above the ground level. You can see here first in the two only I took the cutting. That's it is major cutting. We cannot draw the profile like this zigzag fashion. So I took directly straight line cutting. You can see in the on the profile they have mentioned the G and TL. Right? G is the known as the gradient. It is a longitudinal gradient. Likewise, what is vertical with respect to horizontal, right? It is a now it is showing minus 0.580 percentage. That is now you can see the slope is decreasing. That's why it is taking minus, and the 0.580 it is percentage of slope. And TL is a tangent length. It is 1753. You can see where I took that tangent points, that known as a point of intersection of two tangent, that is PVI, point of vertical intersection. You can see now I drawn all profile. Now I will add the curves. For adding curves we need IRC SP23. Like yesterday I told you, go to the Chrome, type law resources IRC. You will get all IRC codes. In this I will select SP23, right? You can see SP23, it is vertical core for highways. I will click on that. It will get downloaded. Okay. Now I will open. You can go through all this IRC code. I will take what is necessary for design. I will teach that only. Uh, you can see it is all related to vertical curves. You can see. First of all, I will explain what is vertical curve. You can see there are two tangents, like first one tangent, then next one. It is in the vertical direction, right? It is perpendicular to road. You can see in these two tangents, I'm adding the curve, right? For the curves, I will took this. You can see this is a curve. It is a there are two types of curves in the transportation civil 3D and in the engineering also. There are only two types of curves, right? One vertical curve is known as Sumit curve, and other one is a valley curve. There are only two types of curves are there in the design. Now I this curve is known as a Sumit curve. It is a Sumit curve. You can see the curvature is above the. It is towards above, towards
Oh,
sky, right? The curvature is toward the sky.
con
That's why it is called
concave.
as Sumit curve. Okay. Then another curve. It is a valley curve. We'll draw that here. When two tangents meet like this, can see in this there is a plus gradient. It is a plus gradient. It is increasing gradient, and when this is a minus gradient, now it is decreasing. When we will meet plus gradient to the negative gradient, it will create Sumit curve, right? Like that, when we have negative gradient meets with the positive gradient, then it will create a valley curve, right? This is a valley curve. You can see. You can see this is a valley curve. You can see this is a valley curve. Array, what is happening? You can see this is a valley curve, and this is a Sumit curve. This is a valley curve. Okay. These two types are there in the vertical curve, right? Now I will go with the civil 3D. Okay. In this, you can see I will select the profile. You can see here. Here you can see this is a downgrading curve, and this is a upgrading curve. You can see this is a negative gradient, and this is a positive gradient. It is increasing and it is decreasing. Here, what curve will be provided? Tell anyone?
The valley curve.
Right. Here we will provide valley curve. Here you can see this is a positive gradient and this is a negative gradient. What curve will be provided in this?
Sumit curve.
Like same, we will provide all curve like on this same. I will show how to take that curves, right? Click on the alignment, click on profile. You will go like this. On the profile, when you click this window, this vertical horizontal bar will open. In this, you can see geometry editor. Click on that. The bar, horizontal bar will open. Same likewise yesterday what we did for the horizontal curves. Click on the horizontal curve, then go in the geometry editor. Same like that only. We will select for vertical curves. Right now, I want to add the uh, valley curve. Right now, I will go in the curve icon. You can see this curve icon. In this, I will go pre-vertical parabola. This curve will be used in all over India only. I will click on pre-vertical parabola. It will ask first select first entity, then select next entity, specify curve length. You can see in the bottom command bar, they are asking specify curve length or a radius pass through or K. We will select K. I will tell you what is K.
Well,
Okay, we will see IRC code for values of. You can see this table will be used for the vertical curves. On page number 17, IRCSP 23 in 1993, the table is given table 6. This table will be used. You
how
can
to
see,
decide side distance?
I will tell 1 minute. Okay, in this, you can see first column it is design speed, right? They given this is the first one. This is the design speed in kilometer per hour. Right now, our it is a 100 kilometer. We will select this row, right? For any speed, they are all speeds. They are given the values. You can see now our curve is a valley curve. You can see these values are given for the valley curve, right? And these all values given for the Sumit curve. The three values, right? For the valley curve, I will select this. Now for 100 kmph, they have given the value of k, length of vertical curve for the steps length or curve or is greater than the side distance. You can see the title of table, length of vertical curves for different speeds when the length of curve is greater than the side distance, right? As you know, side distance, it is a distance visible ahead for the driver to travel safely on the road, known as a side distance, right? For vertical curves, it will be headlight side distance. For the valley curve, it will be headlight side distance. For Sumit curve, there are three types: SSD, ISD, and OSD. Right? SSD means stopping side distance, intermediate side distance, and overtaking side distance. In that, stopping side distance, it is a minimum side distance. Intermediate, it is a intermediate side distance. Overtaking, it is a maximum side distance. Right? In that, we will select only the intermediate side distance. Right? In India, we will follow only ISD values for the design, because we will take minimum value. It will not be safe for the ISD, for OSD, and if you take OSD, then it will not be economical for the design. That's why we will took middle one, right? It will be safe for the SSD. Also, it is in the economical to the related to cost. Like that, we will select. Now, it is first one is valley curve. I will took this for 100 speed. The valley curve value is given 41.5 A. Now A is the, you can see the notes are given in this. A is the, in the above table is the algebraic difference in the grade expressed in the percentage. I will show in the civil 3D. You can see the algebraic difference means first ingredient it is a 0.522, and the out gradient, see, out gradient is 0.125. The algebraic sum of these two gradients is known as a value. Right now, there is no need for the calculation of algebraic value, that is a value. We will take directly that 41.5 value as the k value, right? These all values are given k. K values that are given in this table multiplied with the algebraic difference of grades is known as the vertical curve length, right? Vertical curve length is a multiplication of vertical curve length equal to k into grade difference, right? The vertical curve length is calculated k into a, right? K values are given in that table. A is the algebraic difference. Right now, we will need only k values for the. You can see in this, when I taken the curve, they are asking three values, right? I will take once again pre-vertical parabola curves. I will do select first entity, second entity. You can see enter k value or radius, length or pass through. We will always give the value of k, right? Now it is asking enter k value. By default, it is a 41.5, right? You can see in the table, it is a 41.5. Because it came because we already set the IRC code. That's why it is taking directly, right? I already in the vertical profile drawing, we already took the IRC SP23 as a design criteria basis. That's why it is displaying 41.5. Like that, we will import the k value. Like minimum value is 41.5. Above that, all values are okay. Now I'll give 60 as a k value. Sorry. You can see the curve, valley curve now taken here. You can see this is a valley curve. You can see the tangent, the two tangents will meet at this point, and the curvature is above that point. That right? Like that, what we seen in the this, can see the tangent points meet at the below, and the curve will be above that. In valley curve, in Sumit curve, the tangent will meet at the top, and the curve is below the that point of one vertical intersection, right? Like that, all valley curve will be done like this. Now I will give example of, now I will give example of that Sumit curve, right? Here you can see this is a positive gradient meets negative gradient. That's why we are providing Sumit curve. In this also same process, select the profile, go in the geometry editor, go on the pre-vertical curve parabola, select on that. Same it will ask, select first entity, select second entity, and enter k values, right? For k values, we will go intermediate side distance, and for 100 speed meter, they have given 135, right? Minimum value it is 135. You can see it is already saying the 73.6 value it is taking. By default value it is 73.6. Why it is taking?
23.
Because it is taking the stopping side distance. You can see for 100 speed there is given 73.6 stopping side distance, right? Now we
But
will provide all values for the, yes, yes,
In
what?
India we can design IST, no? You have told, no?
Yes, yes. We will design for ISD, but the Civil 3D kept SSD as a by default value. We will input ISD values only, right? For 100 speed, there we given 135 as a minimum value. Now I will give the value 140. Like that, all curve will be done. I think everyone understood. Vertical profile. Anyone have any
Sir,
doubts regarding this?
sir, that minimum value what we provide more than minimum, we can randomly or we have to calculate
No, we can give randomly.
sometime.
Minimum values are given in the IRC code. Above that,
Hmm.
any value will be accepted. Okay, I think everyone understood. I will give one more curve. You can see this is a valley curve. I will give valley curve in this area. You can adjust this vertical point of intersection with respect to the ground profile. See, there is a use cutting. How to see the how much is cutting? It is given in this bottom table. You can see now it is 0 0. We will set that. Select the profile view. Go in the profile view properties. You can see here profile view properties. In that bands, go in the bands. First one it is cut fill. You can see cut fill. Cut fill is the difference of design profile and existing profile, right? And the FRL it is all will be design profile. You will select here, and the ground will be existing ground. Then change will be the design changes, and the vertical geometry will be design profile 1 it is a design, and profile 2 is a existing surface. Like that you will select all, apply, click OK. You can see now it will be visible. You can see there is a first one, it is cutting section around 15 meter, there is cutting. Please
स्टॉप
mute,
करने वीडियो
please
बताइए
mute,
यहाँ रहूंगा
please
मैं
mute.
जहाँ
You can see all values are updated here. You can see there is a 18-meter filling. This much filling will not be granted for the expressway. Can decrease the filling. How to decrease? Only by adjusting the vertical profile. Select on that profile and take it down. You can see. Okay. Like this, we will adjust all. You can see this, there is a maximum filling. We will reduce this. Why we provide filling in the expressway? Anyone knows?
Sir, access control for better access control.
That one point, but is not related to vertical curves or on horizontal curves. I need specific answer.
for smooth gradient.
That's one right answer. When we provide on the horizontal curve, you can see this is the horizontal curve profile. When we touch the ground surface, it is very undulating surface. You can see there is a drastically change in the surface, right? That's why we provide higher elevation to give the design as a smooth way, in the smooth way. You can see now I will provide the valley curve in this. Let's select on that, go in the geometry editor, go in the pre-vertical, select pre-vertical curve, then select first tangent, second tangent, k value, it is 41.5 is minimum value, I select 50. You can see the curve added. Like that, all curve will be added, then it will become the profile, right? You can see this all value, this is a proposed elevation, and this is the existing elevation, and this is change. I will tell you what is vertical schematic. You can see in this vertical schematic, the first one is already, it is all straight, right? When we provide the curves, there you can see it will shows like this. Before that, it is all straight line, right? After that also it is all straight line because there is no curve. When there is curve, that in that say in that portion it will show the curve, right? When it is a valley curve, it will curvature will be down to the earth. When there will be sumit curve, in that portion you can see the curvature towards sky. In that you can see they have given two values. One is the length and uh, second value is k, right? Length is a length of vertical curve. K is the value as per IRC code, right? K is known as a curvature. It will denote the amount of curvature. If it is lesser value, it will shows more curve. If it is higher values, it will shows the curvature is less, right? Like in the horizontal curve, we tell how much is the radius. If r is more, then the curvature is less. If radius is less, then the curvature will be more. Like that, in vertical portion, we will denote with the k values. Like that, this will
Sir,
profile.
can you repeat कर दो sir.
Which one?
Sir, this relation curve and radius and curvature.
Okay, okay. If the in the horizontal curve, we denote the curvature as a with respect to radius. If the radius is more, the curvature will be less. For the straight line, the radius is tends to the infinity. Because there is no curvature, that's why it tends to infinity. That is larger value. For if the radius is small, then the curvature will be more. Like that, in vertical curves, we will denote the curvature with respect to the k values. The curvature is k value is less, then the curvature will be more, right? If the k value is more, the curvature will be less. Like that, it will be. It is opposite to the radius. Please note that. Okay, like this, we will do all the curves. Then the profile will be generated. This is related to the profile. Now, anyone have any doubts? Shall we
Sir,
move to the superelevation?
Is there any criteria for changing the changes of grade?
Grade, there is no criteria, only the
No, but
K
how
value.
much distance?
If the more K value we choose, the curvature will be less. The based on the IRC SP23, we will choose the K values. Minimum values are given in this table. We provide more than this. If you provide more than this,
uh,
the design will be safe.
It can be
sir,
take the
that
tangent length of 50 meter and 20 meter if it
What?
is
What?
tangent length. How
Tangent
much
length,
tangent?
with we can provide anything. There is no criteria. Tangent
No
length,
correct.
the distance between two point of vertical intersection, minimum it is 150,
Okay,
right?
point of vertical intersection.
The distance between PVI, two PVI, minimum it is 150. It is allowed minimum 150. Above 150, it will okay.
In between PVA, you are asking,
In
it
between
means?
two PVI points.
Okay, okay. Sir, that minimum gradient we have to maintain 0.3%.
That is also one of the criteria. In this, the gradient, you can see this is a this gradient minimum it should kept at is a 0.33 percentage minimum gradient. Above that, you can provide any gradient, and it is restricted to 7%. More than 7%, it is not allowed in the design, and below 0.33, it is also not allowed. In between 0.33 to 7%, we can provide gradient.
सर जैसे जहाँ नहीं है वो कैसे एडजस्ट करेंगे एक बार थोड़ा सा बताओ.
जहाँ नहीं है वह स्ट्रेट लाइन हो जाएगा. You can see here, the point of intersection will not come. Now I will delete in this area. You can provide the horizontal line. You can see this is total horizontal line from here to here. There is no curve. Like this, we can also provide. If it
और
is
सर जैसा
necessary
उसमें
to provide the curves, then only we will provide curve. Yes.
एंड सर दैट क्राइटेरिया सर जैसे कंक्रीट रोड में बोलते हैं 2.5% देना है
Oh,
और
that is
जहाँ
not
ज्यादा.
related to the
हाँ हाँ हाँ.
gradient. It is a camber slope. We
ओके
will
सर.
discuss this in the assembly lecture, assembly and corridor lecture class. We will see that there in this. Okay, we
नो
will
सर वो
now.
लिमिटिंग ग्रेडियंट आई वाज
Gradient
आस्किंग, दैट
gradient should be
लिमिटिंग.
decided on the basis of the terrain. No?
हाँ यस सर.
Terrain. In the IRC code, you can go through the IRC 2-lane IRC code. They have given the
Hmm.
values for the plain terrain, hilly terrain, and
There is ruling gradient, limiting gradient, exceptional gradient. There is three type of the
there
gradient.
is
No?
one. That is, I am telling the 7% is the maximum gradient
Yeah.
that we can provide, and minimum is a 0.33. For the drainage purpose, minimum gradient should be 0.33. Anyone else? Okay. Shall we move to the.
Means sir
Yes.
we can provide 0.3 to 7% while creating a profile.
Yes, yes. Okay. We will move to the superelevation. Superelevation, it is a simple. Only first we need to select the alignment, and you can see this horizontal bar will change. Here you can see there is a super elevation icon. Click on that super elevation. Calculate edit super elevation. Click on that. It will automatically calculate the super elevation. Now we need to decide the carriageway. Now it is a undivided carriageway. You can see undivided crown means there is a center point, and both the carriageway, left center and right carriageway, it is a center toward the center point. You can see in the undivided planner, the curvature, both curve will be in the not the central point. It is a edge point. You can see at the edge, the both the planes are set together, right? In the divided crown with median, you can see the both carriageways are separated with the center of each carriageway. In the divided planar with median, it is also same like that undivided crown. You can see the both uh, carriageways are centered towards the center point of total ROW. Like that, we will select undivided crowned area. Center as a baseline. You can see next. I will click on the next. Now we will input the normal lane width. You can see for the IRC, as per IRC, they have given the uh, carriageway width. For expressway, it is given. You can go through the IRC code of expressway. They
3.7.
have given 3.75 as the lane width. Now we
Hmm.
are providing 6 lane width. Then 3 lane on left carriageway, 3 lane on right carriageway. Like that, we will take multiply with 3. Now it will show calculate to the 11.25 as a carriageway width. Now we will provide the paved shoulder as a 3 meter. You can go through these values are given in the IRC SP99 expressway IRC code. In that, the carriageway width is 3.75 lane width and the paved shoulder is 3 meter. Now you can calculate this all 3.75 into 3 plus 3. It will goes to 14.25. Now the normal lane slope that is camber, right? For the rigid pavement, we will provide minus 2%, right? For the flexible pavement, minimum it is minus 2.5%. Like that, now we will consider rigid pavement. We will provide minus 2% as a gradient. I will go next. In this normal shoulder width, it is 1.5 and the shoulder slope, it will be plus zero point 0.5 of carriageway slope. Now we provided 2% as a carriageway slope, carriageway camber. It will plus zero point 0.5, it will goes to the 2.5, but the minimum IRC code says minimum 3% will be shoulder slope width. Like that, we will provide 3%. Then next click, you can select this IRCSP 19 as expressway code, all lanes. Then these all will be default. In curve smoothing, apply curve smoothing. Select and by default value it is 20. When two curves are provided on the there, then the smoothing will be taken as a 20-meter length. It is by default. Then click on the finish. It will calculate all the super elevation along the curves, right? Now I will click on this. Okay, click OK. Now all super elevation will be calculated, right? You can see first I will show what are the curves, right? In the geometry editor,